So we solved in the previous video the equation based on this square root of x minus 9 and 5. This time I've changed it into an inequality. Now, throughout this class, we have solved different inequalities. We've solved absolute value inequalities. We have solved quadratic inequalities. We have solved rational inequalities. This is the next step, and we've done the same thing every time. The first thing we do is solve the equation. Please do not make the mistake of just squaring both sides of this. It is not going to get you to your destination. I promise you, I've graded tests in this class before. So the first thing to do is solve the equation, and you can go back to the previous video. We solved it and we've got 34. The second thing we've done in all of these inequalities is we have used the number line test. And what we've done is we've used a number line to represent the domain of the function. And so when we did absolute value inequalities and quadratic inequalities, since the domain of those functions was all real numbers, we used the whole number line. For quadratics, if you remember those videos, we put an asymptote with the values that were not part of the domain. So what we're going to do is our radical function has a limited domain, and there's previous videos. Look up in your Canvas course and you'll see it. What we're going to do is we're going to find the domain of this. So what is the domain of the square root of x minus 9? Well, what we do when there's an even index is I just take the radicand and I say x minus 9 has to be greater than or equal to 0. And so what that means when I add 9 to both sides is that the domain is all values greater than or equal to 9. So what that means for my number line test is this. I'm not going to use the number line that goes infinitely in both directions. I am going to create a number line that starts at the value 9 and then is bigger and just goes in one direction. Now I'm going to put my value 34. This is in the domain. That's my point of equality. So now I have two intervals on the number line. Notice this left-hand interval, this is not negative infinity. I have chopped off the whole negative infinity part of the number line because it's not part of the domain. So my domain starts at 9. So my first interval is from 9 to 30. Oh, sorry, miswrote. You're probably wondering why. 9 to 34, and then the second interval is 34 to infinity. Now we're going to test these out. So I'm going to just pick a value from each of these intervals. So I'm going to pick 10. 10 is between 9 and 34. And when I put 10 in here, 10 minus 9, that's the square root of 1. This side is 5. 1 is less than 5. So in this interval, I've got less than. And then from 34 on, I'm just going to pick a value like 36 or something. And so when I put 36 into the problem, I've got 36 minus 9, and I've got to think about that. That's 27 and 5. And you can pop that into your calculator. Square root of 27 is 5 point something. And the way I know that is the square root of 25 is 5. So since 27 is bigger than 25, the square root of 27 is bigger than the square root of 25. But use your calculator. And so this part of the interval is greater than. So the question I asked at the beginning is, when is the square root of x minus 9 less than 5? Well, that is in this interval right here. So the interval is going to be from 9 to 34. Now, I'm not interested in the point of equality, so I'm going to put I'm going to put a parenthesis there. Maybe you just heard my cat meow. It's very excited about this problem. Here's the thing. When I put 9 in, 9 minus 9 is 0. 0 is less than 5. So I know that there's no equal in this, but because of the limited domain, and the domain starts at 9, this is going to have a bracket. So test that for yourself. If I plug 9 in, 9 minus 9, I get a value on the left that is less than the value on the right. And so my solution to this inequality is 9 to 34.